All right, problem number 3. This is a rational function. We will deal with the domain in a little bit. We're not going to worry about the range. We're not going to worry about a minimum or a maximum. So the domain is going to be restricted by values that make our denominator 0. And we can't have the 0 in our denominator. So for our domain, we're going to look at x squared minus 5x plus 6 equals 0. So we need two numbers that multiply to 6 and add to -5. It'd be -3 and -2. Set each of those factors equal to 0. So if x was 3 or x was 2, our function would not be defined. Those are two asymptotes. We'll fill that in. I like to draw my asymptotes in red. Reminds me of a stop sign. Now, x can take on any other value. So for our domain, ooh, that was bad. Let's try that again. We would have all x such that x is not 2 or 3. That's just a quick and easy way to write that. We could also have a horizontal asymptote. And for that, what we do is we look at the largest power of x in the numerator and the denominator. And then we reduce. There's a common factor of x that reduces out. We get 1 over x. As x gets larger, one over x goes to 0. So that's another asymptote, y equals 0. This is a y equals. All right. For the x-intercept, that's going to be where our function is equal to 0. So x plus 4 over x squared minus 5x plus 6 equals 0. I'm going to think of that as 0 over 1, and I'm going to cross multiply. So we get x plus 4 times 1, which is just x plus 4. And that equals x squared minus 5x plus 6 equals 0, or times 0, which is 0. Solve for x, we get x equals -4. For the y-intercept, I simply plug 0 in for X. Which is the same as 4/6 or 2/3. This is one I would suggest picking some more values and plugging them in. And what you're going to find is this graph does something like that. It will have a point down or a spot down here. And that part's going to look something like that. Again, we're not going to worry about range. We're not going to worry about a minimum or a maximum.